Hi and welcome to Maths class. In our last video we started looking at expanding two pairs of brackets like these, like the ones you see in front of us. We first practiced using FOIL, firsts, outsides, insides and lasts, and in the last video we learned about a difference of two squares. So today we're going to look at a new pattern for expanding brackets, and it's really important that we learn this pattern because later when we want to factorize we use the pattern, and without the pattern we can't do them. So let's start by just looking for patterns in the example, and what I want you to do is simply expand all of those brackets using FOIL and see if you can spot a pattern as you go. And if you can spot the pattern, then test it by predicting what you think you're going to get, and then have a look at my video and see if you get the right answers. Okay, so I'm not going to offer any kind of explanation. I'm just going to go right ahead and expand these brackets. So let's get started. Okay, so hopefully you spotted a pattern, and the pattern can be seen quite clearly even as you're in the second line of your working, that we always double up these middle terms here. We go plus 2x, or plus 3x, or plus 6x plus 6x. And this term comes from the x times the 3, or in this one it comes from the 2x times the 3. So in fact what we have here is a situation where if I write down this is a plus b multiplied by itself, then the pattern I get is I get the first term a squared, then I do a times b twice, and then I do the second term squared. So I multiply the first term by itself to get a squared, then I multiply the first term by the second term and add that twice, and then I square the second term. So I get a squared plus 2 times ab plus b squared. And this is our formula. So let's go to the next slide. What do you think the rule is for expanding a plus b times a plus b? Well, the first thing is when I write a plus b times a plus b, I'm actually going to rewrite that in a shortened form as a plus b squared, right? Because that's what this is. If I multiply a times b by itself, then I'm squaring it. And the formula is a squared plus 2ab plus b squared. It's not as pretty a formula as the difference of two squares, where we went a squared minus b squared. It was nice and easy. This one's a little more complicated, but if you remember that this middle term is just each thing multiplied by the other, the first term multiplies by the second term, and then I double it. So to do a quick example, if I did x plus 5 and I square it, I'm going to square the first term, so that's x squared. Then I'm going to go the x times the 5, which gives me 5x, and then double it, so that's 10x. And then I square the second term, 25. Okay, let's practice some. Okay, so remember that this is my rule. A plus b squared equals a squared plus 2ab plus b squared. So once again, what I want you to do is pause your video and practice these yourself and then hit play and see how you go. Now, if you do get stuck, of course, feel free to hit play and watch me do them. I'm going to talk through these ones. So what I'm going to do again is I'm going to remember that x is my first term and 6 is my second term. So x is like the a in this formula and 6 is like the b. So I'm going to square the first term, so I get x squared. And at the end, I'm going to square the last term, so I'm going to get 6 squared, which is 36. And in the middle, what I'm going to have is these two multiplied together, which gives me 6x, and then double it, which gives me 12x. Okay, let's try that again. My first term and my second term, I square the first term, Then I multiply them together to get 11x. Then I double it to get 22x. And then as my last term, I square the 11, 121. Now, I can tell you now that one of the most common mistakes I see people make here is things like they double this number. So instead of 121 here, I would see 22 written. They're kind of careless little errors. So make sure that you focus on following this and check that you're doing the right thing each time. So let's try the next one. I'm going to square the first term. Now be careful. This is not 3y squared. This is 3y all squared plus 3y times 1 gives me 3y, then double it gives me 6y. And finally I add the 1 squared, so that gives me 9y squared plus 6y plus 1. Let's look at this one. I'm going to square the first term, 2x, so that's going to give me 4x squared. Then I'm going to multiply these together. 2x times 5 gives me 10x, then I double it, gives me 20x plus 20x. And then I square the last term. So I square the 5 and I get 5 squared is 25. Okay, let's do another one. This one's slightly different because I've got a y here, but my technique is exactly the same. I square the first term, so 3x squared is 9x squared. So remember always when you've got a coefficient in front of the x, I have to square this 3 to get 9, as well as squaring the x to get x squared. Then I've got to multiply them together. 3 times 4 gives me 12xy. Double it gives me 24xy. And finally, I square the last term. That's going to give me 16y squared. Same deal. I had to square the 4 as well as squaring the y. Okay, the last example is a little different, and I want you to remember that if this is a, x, then my b is this number here, -2. It's the whole number -2. It's not just the 2 part. Okay, so I'm going to square x. That gives me x squared. Now I'm going to multiply the x times the -2. So that gives me -2x. Then I'm going to double it. That gives me -4x. And then I'm going to square the -2. Now the fact that it's negative doesn't help it. If I square a negative number, I still get a positive result. So that is plus 4. Okay, so let's have a look at a summary. For my perfect squares expansion, when I've got two identical brackets that are multiplied together, and that's what I've got here, a plus b squared, and sometimes you'll see it written like this, x plus 3 times x plus 3, and sometimes you'll see it written like this, x plus 3 squared. Those two are the same. So if you see that, you know you've got a perfect squares expansion. Then we can skip FOIL and use the shortcut rule. Now, once again, it is possible to use FOIL, firsts, outsides, insides, lasts. So if I had it given to me like this, I could write it out like this. And then I could go firsts, outsides, oops, I missed, insides and lasts. But it's quicker to use this. And also when we learn factorizing, it's really important that you've had practice using this. So please, if it's a perfect squares expansion, use the formula to do it. Now we're not done with these guys yet. Looks like we are, but we're not. Let's take it further. What happens when the brackets have a subtraction? Now we've already looked at one of those, but I want you to do the same thing again. Use FOIL with them and then predict what changes every time in the rule. Okay, so pause it. Do them yourself and then check my answers. Okay, how'd you go? So what you can see here is that we still have a repeating pattern in the middle two terms where I go minus 2x, or minus 5x minus 5x. So I'm still doing the doubling. The only thing that's really changing here is that this is always negative. So you've really got two choices here. You can learn two formulas, or you can use the one formula and just remember that your b term is -2, not 2. So let's summarize this. Oh no, we're going to practice it. Okay, let's go back first then and write out what the rule is. We haven't done that. So if I've got a minus b all squared, then my rule is going to be a squared minus 2ab plus b squared. So it's exactly the same as the previous rule, but I've got a negative in there, which means I'm going to have a negative in there. Okay, so now let's do some practice. Once again, pause your video, do them yourselves, and then come back and check the answers with me. So what I'm going to do is I've got my a squared, so that's x squared. Then I'm going to subtract x times 3, which is 3x, double it is 6x, plus 9. Or the other way I can think about it is I've got x squared, and then I've got x times -3, and I double that to get -6x, and then I square my -3 to get 9. Okay, I'm going to have x squared. X times the -5 is -5x, doubled is -10x, plus -5 squared is 25. 6 squared is 36. 6 times -x is -6x, doubled is -12x, and then -x times -x, that's -x squared, is plus x squared. That's -x all squared, right, like this. That gives me that. Once again, square the first term, gives me 25x squared. Then I subtract double those multiplied together, so 5x times 1 is 5x, makes it minus 10x, and then add 1. 1 squared is 1. This one gives me 16x squared minus 24x plus 9. The 24 comes from 4 times 3, doubled. This is going to be 4m squared minus 20m plus 25. So I've got this 2 is squared to make 4, and then the 2 times the 5 gives me 10, double it gives me the 20, and then the 5 squared is 25. This one's going to give me 9x squared minus 30xy. Be careful, I've got an x and a y here, plus 25y squared. So this came from 3x times 5y is 15xy, doubled is 30xy. And finally, 5c minus 3d all squared is going to give me 25c squared minus 30cd plus 9d squared. So now I'm just going to take you to a summary of everything we've learned in this video. For the perfect squares expansion, you've got these two rules. A plus b squared is equal to a squared plus 2ab plus b squared. In other words, I square the first term, that's here. I square the second term, that's at the end. And in the middle, I multiply them together and then double. And down here, everything is the same, but if I've got a subtraction in my bracket, then the middle term, the doubled term, is negative, but everything else stays positive because when I square a negative number, I get a positive result. And that's the end of our video.